Welcome to Across the Globe. Today, we will learn about data analysis basics with Pandas. Pandas is a powerful Python library designed for data manipulation and analysis tasks. It introduces useful data structures such as Series and DataFrame, which are essential tools for handling structured data. For instance, when working with a dataset containing information on sales transactions, Pandas enables you to clean the data by removing duplicates or handling missing values efficiently. Moreover, Pandas facilitates data transformation tasks, such as concatenating multiple datasets or reshaping data structures to suit specific analysis requirements. Additionally, it empowers users to explore and analyze datasets effectively by providing various functionalities for filtering, grouping, and summarizing data. In summary, Pandas serves as a fundamental tool for tasks like data cleaning, transformation, and exploration, making it a valuable resource for data analysts and scientists across industries. To create a data frame using the pd.DataFrame constructor, you can pass a dictionary or list containing the data you want to include in the data frame as an argument. Each key in the dictionary or element in the list will correspond to a column in the data frame. The values associated with each key or element represent the data for that column. For example, in the provided code snippet, a dictionary with name and age keys is used to create a data frame with columns for name and age, populated with the corresponding data. This approach is commonly used in real-world applications where structured data needs to be loaded into a tabular format for further analysis or processing. For instance, a company may use this method to convert a dictionary of employee information into a data frame to easily view and manipulate the data. To read data from a CSV file into a data frame, you can use the pd.readCSV function in Python's Pandas library. This function takes the path to the CSV file as an argument and returns a data frame with the data from the CSV file. To write a data frame to a CSV file, you can use the df.toCSV method on your data frame object. You can specify the file name you want to write the data frame to, and include parameters like index equals false if you do not want to include the data frame's index in the CSV file. For instance, if you have a file named data.csv and want to read its contents into a data frame named df, you can use Python df pd.readCSV data.csv. Subsequently, if you wish to write this data frame to a new CSV file named output.csv without including the index, you can execute Python df.toCSV index false. To examine the initial rows of a data frame, the df.head method can be used. This provides a quick preview of the dataset. Next, utilizing df.info offers a concise summary, including the data types and count of non-null values in each column. Finally, the df.describe function presents statistical details like mean, standard deviation, and quartile information for numerical columns. By executing these commands, you can efficiently explore and understand the structure and characteristics of your dataset. When working with data frames in Python, you can use square brackets to select columns or rows. For more complex selection, utilize df.lock or df.ilock. To filter data based on certain conditions, use Boolean indexing. For instance, to select a specific column named name, you can use df.name. To filter data where the age column has values greater than 25, you can employ df.dage25. Data analysis basics with Pandas is like organizing and categorizing a messy closet full of clothes. Just as you would sort through and arrange different types of clothing, shirts, pants, socks, in the closet, Pandas helps organize different types of data, numbers, strings, dates, in a data set. You can use Pandas to filter out specific clothing items you want to wear, similar to how you can use it to filter out specific rows or columns of data you want to analyze. By utilizing Pandas functions like groupBy and mean, you can calculate average sizes of clothing or average values in a dataset. Creating a Pandas program to analyze data is like creating a system to automatically clean and organize your closet based on certain criteria. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The code snippet begins by importing the Pandas library as PD. We have a messy dataset containing numeric, string, and date data stored in a dictionary called data. We then create a DataFrame df using pd.DataFrame to represent this messy data. The initial dataset is printed using printdf. Next, we filter out specific rows where the numbers column is greater than 20 using Boolean indexing, similar to selecting specific clothing items from a messy closet. The filtered dataset is printed using print filtered data. We calculate the mean of the numbers column to get the average number, akin to finding the average size of clothing items in the closet. The average number is printed print f n average number. Further, we group the data by the strings column and calculate the mean of the numbers column within each group. This grouping and calculation are similar to organizing clothes by type and finding the average size within each type. The grouped data is printed using print grouped data. This code demonstrates basic data manipulation techniques in Pandas, which can be applied to analyze and organize various types of messy data sets, similar to organizing and analyzing a messy closet. Analyzing data with Pandas can be likened to organizing a messy closet. Just as we sort through and categorize clothing items, we manipulate and manage data for meaningful insights. Let's consider two industrial examples where Pandas is crucial. 1. Retail inventory management. For retail businesses with diverse products, Pandas simplifies inventory analysis. By using data filters on sales figures, retailers can identify top-selling items and restock accordingly. Just as we filter data in Pandas to find specific rows, retailers filter product data to optimize inventory levels. Financial data analysis. In the finance sector, Pandas is employed for analyzing market data trends and investment performance. For instance, calculating the average returns of certain asset classes mirrors calculating average values in a data frame column. By grouping financial data based on attributes such as asset type, analysts can derive valuable insights akin to grouping data in Pandas. Across the globe, Pandas empowers industries to harness the power of data for informed decision-making, much like organizing a messy closet to find the right outfit. Keep learning, stay curious, and I'll catch you in the next video.